See students, so this is a finding refractive index of a prism lab activity. So for this we required prism, white chart, drawing board, protractor, pencil, scale, etc. If you want to do the experiment with a laser light. Okay, na? Yes. So we have already so this is the prism. So it is made by the glass. See here, it has two triangular surfaces and three rectangular or else square surfaces. Okay, na? See, to do this activity, so we have to take the prism on a drawing paper in this way. Now you draw its outline. Okay, it's a outline. Yes. Now take a vertices of a triangle as A, B, C. Okay, na? So here is a AB surface and a AC surface. On the AB surface, above the middle, you take one point, you select one point. Okay, na?
Yes, sir.
Now, using the protractor. So you place the protractor as it's a horizontal line coincides with the AB surface, and that a junction on the protractor coincides with the point we took on AB surface. Okay, na? Yes. Now put a dot at a 90 degree. 90 degree. Okay, na?
Yes, sir.
Yes. So take one more point at a 60 degree. I will tell later why this is. Okay, na?
Yes, sir.
At a 60 degree one point. Now join these 2 points which was taken at a 90 degree and point which was taken on the AB surface. Okay, na?
Yes, sir.
This acts as what, ma?
Normal, sir.
Very good, super. This acts as a
Normal,
normal. Okay, na?
Yes, sir.
So at 30 degree we took one point.
Yes.
So what is the angle between 90 to 60, ma?
30.
Okay, na? 30 degrees. 90 to 80, 80 to 70, 70 to 60.
60.
30 degrees.
Yes, sir.
Now join a point which is at 60 degree and point which is at AB surface. Okay, na?
Yes, sir.
Yes. Okay, na?
Yes,
I
sir.
joined, ma, and extending this line with the help of dots. Later I will tell why I am extending this incident light ray. Okay, na?
Yes, sir.
Yes. So how this line acts, ma?
Incident light.
Good. This is a incidental
Incident
light
light
ray.
ray.
This is incidental light ray.
Light.
Incidental
Light ray.
light ray. So here angle of incidence is what, ma?
30 degrees.
Very good. I is equals to 30
degrees.
I is equals to 30 degrees. Okay, na?
Yes, sir.
Yes. So now we can do this experiment with the help of laser light or with the help of pins also. Okay, na?
Yes, sir.
So both I will tell. With the help of a pins how we do. With the help of a laser light how we do. Okay, na? So already I said refractive index of a prism n is equals to sin of a plus dm by 2 by
Sin A by 2.
sin a by 2. This is the formula.
Yes, sir.
Here a is angle of the prism.
Prism.
Angle of the prism means angle between any two surfaces. Okay, na?
Yes, sir.
So in the triangular shape, angle between any two surfaces is called angle of the prism.
Prism.
So it is a equilateral triangle And we know in a equilateral triangle,
All sides
each angle is a
60 degrees.
60 degrees. Okay, Nama?
Yes, sir.
So here we know it's a angle of the prism as a 60 degrees. So otherwise with the help of protractor, if you measure, you get the same 60 degrees.
Yes, sir.
Okay, na? If you measure here on the diagram between the two surfaces angle, you will get same 60 degrees. Okay, na?
Yes, sir.
DM is what?
Angle
of minimum deviation. To find the angle of minimum deviation, so we have to do this lab activity. Okay, na?
Yes, sir.
So with this in this lab activity, we will find the angle of minimum deviation. Okay, na?
Yes, sir.
Yes. Now, so we'll do with pins first, ma.
Okay, sir.
Okay. So you press or else you take two pins on the incidental light ray. Okay, na?
Yes, sir.
Two light rays. Sorry, two pins on a incidental light ray. So in this way. Are you able to see on the screen, ma?
Yes, sir.
Okay. So I took two pins on a incidental light ray. Okay, na?
Yes, sir.
Now place the prism on its outline. Okay, na? As the prism coincides with the outline. Okay?
Yes.
Yes. Now we have to see those two pins. Those two pins. We have to see those two pins through AC surface. Through
Yes, sir.
AC surface. See here. This is a AB surface. Here we took two pins. Okay, now
Yes, sir.
we can see its images here. If you see through AC surface. Okay, now
Yes, sir.
if you look through AC surface, you can see its images here. By observing these two pins, that is through the lens, we see images only.
Yes, sir.
Okay, na? By observing these two pins, so here we have to fix two more pins in such a way the images of these two pins and these two pins lie on a same
Vertical line.
On a same line. Okay, na?
Yes, sir.
Yes. Now see here. So at the prism level height, so we have to take our eye. Yes. Yes. So by observing those two pins, so we have to fix two more pins, as all those four lie in a same line. Okay,
Yes, sir.
in this way. Okay, Namma?
Yes, sir.
Yes. So you take two pins which are on a incident light ray as remove these two pins. Okay. So I put dots in those positions. I take as a P,
Q.
Q. So here I remove these two pins and I put two dots and I take these are as a R and a S. Okay, Nama?
Yes.
Now I extend these. Okay, now by joining these two pins, I extend. See here. This is a This is emergent light ray. Okay, na?
Yes, sir.
This is emergent light ray. Okay. So previously I extended a incident light ray
Yes.
in the form of a dotted line.
Yes, sir.
Now we have to extend this emergent light ray to back
In the form of
in the form of a dotted
Dotted
line.
lines.
Okay. Yes. In the form of a
dotted lines.
Okay, now.
Yes, sir.
So those two dotted lines intersected at this point. Okay.
Yes, sir.
See here, this is a incident light ray. If there is no prism, it continues its path in this direction.
Yes, sir.
But because of the prism, light deviates from actual path. Okay, na? And the deviated light ray is nothing but this emergent light ray. This emergent light ray. Now, the angle between actual path of light and the emergent light ray, or that is a deviated light ray, is called as angle of deviation. So you take with a small d or else delta, no problem. Okay, na? Small d or else delta. That is angle of deviation. Small d or a delta. Now you measure this angle of deviation. See here, protractor. You take the horizontal line of a protractor coincides with the incident light ray, path of incident light ray, and the junction point must coincide with the intersecting point. With the intersecting point. Okay, now?
Yes, sir.
Yes. Now you measure 10, 20, 30, 40, 50, 51, 52, 53. Okay, now? So here angle is what? 53 degree. For I is equals to 30 degrees. Angle of deviation we got is what?
53 degrees.
53 degrees. Okay, na? So in this way we have to do this activity with the help of a pins. So now we did with I is equals to 30 degrees. Later you continue, you repeat this activity for different angles of incidence. That is I is equals to for 35, for 40, 45, 50, 55. So up to 55 degrees you take angles of deviations. Okay, na?
Yes, sir.
So you will get the angles of deviations values in the decreasing order, and from a particular value further angle of deviations increases. Okay, na? That a particular least angle of deviation is nothing but angle of minimum deviation. Okay.
Yes, sir.
So further we draw graph between angle of incidence and the angle of deviation. So we get the shape of the graph as a parabola. Okay. When we draw the tangent to the parabola graph, that intersect the y-axis at one point. Okay, now on that axis we take angle of incidences. Okay. So the value at which that tangent intersected is called as angle of minimum deviation. Okay, na? So by drawing ID graph means
The graph
graph between angle of
incidence and angle of deviation.
We will get angle of minimum
Deviation.
Okay, na? So in this way we do this activity. Okay, na? So you have to take 30 degrees, 35,
40, 45, 50, 55.
Now see here, so how with the laser light? So because this is a light chapter, so it's a good if we use a light. Okay, na? So no problem, it's not, there is no any restriction, so to do with the pins only. Okay, na? So in the high school level, whichever is easy, we will do with that by using that equipment. Okay na? Yes. See here. So here light is incidenting. Okay.
Yes, sir.
At I is equals to 30 degrees along the incident light ray. Okay na? And you see it's just a minute. Okay, so here is its see here it's the emergent light ray. Okay, here it's the emergent light ray. So already we drawn one line, emergent light ray, with the help of pins. Okay, so with the laser light also the line is passing along the same line. Okay na? The laser light also passing
Along the
line,
same line.
along the emergent line already drawn. Okay na? So everybody, are you observing ma?
Yes, sir.
See here, this is a incident light ray. Okay na? This is incident light ray, and this is what?
Emergent
This is emergent light ray.
angle of deviation.
This is emergent light ray. Okay na?
Yes, sir.
Yes. That means the same angle of deviation we got with both pins
And laser light.
Laser light also. Okay na? Did you understand? All of you? Yes. So already I explained at angle of minimum deviation, that is what happens. Yes? What are those points, ma?
Angle of incidence is equal to angle of emergence.
Very good.
Next, the light,
Yes.
the path of the light ray inside the prism is parallel to the base of the
Very good. So here I said that there is two angles R1, R2.
Yes, sir.
One is in AB surface, that the angle of refraction. R2 is in AC surface, that the angle of incidence while light traveling from glass to lens, prism to air. Those R1, R2.
Yes, sir.
Okay na? At the angle of minimum deviation we discussed that angle of incidence is equals to angle of emergence, and
The light ray process
R1 is equals to R2, and the path of the light inside the prism
is parallel to the
is
base
parallel
of
to its base.
base
Okay na?
of the
So
prism.
these 3 points you must remember what happens at the angle of minimum deviation.
Yes, sir.
And the next one is, how do you get the angle of minimum deviation?
By using ID graph.
By drawing
ID graph.
from ID graph we will get
Angle of minimum deviation.
so is it okay to all?
Yes, sir.